In this video lesson, I'm going to look at calculating the shortest distance between a line and a point. So let's take a look at this question here. So it says calculate the shortest distance between the line 2x plus 3y is equal to 6 and the point 7 and 6. Round your answer to one decimal place. So when tackling a problem like this, it's always good to first try to graph what we're given. So I'm going to start by graphing 2x plus 3y is equal to 6. But before I do that, what I'm going to do is I'm going to change this into slope y-intercept form, just so it would be easier to see what the slope is and what the y-intercept is. So starting with this, what I'm going to do first is I'm going to move the 2x over to the right. So I'm going to have 3y is equal to negative 2x plus 6. And now I'm going to divide both sides by 3 to isolate for y. So y is equal to negative 2 over 3 x plus 2. So this is the slope y-intercept form of this equation. So we can tell that the slope is negative 2 over 3. So m is equal to negative 2 over 3. And the y-intercept b is 2. Okay, so b is equal to 2. So graphing this, what I'm going to do is I'm going to start at 2. So 2 is over here. And I'm going to go, so the rise in this case is going to be, it's actually, well, the rise is going down because it's negative. So I'm going to go down 2 and 3 across. Okay, so going down 2, 1, 2, and then going 3 across. It's going to give me a point that's over here. And then doing the same thing, going down 2 and 3 across is going to give me a point that's over here. So now I have 3 points. I can also go 3 to the left and 2 up to just get another point. So these 4 points are on this line. So what I'm going to do is I'm going to connect the points. Okay, and then just extend this a little bit. Okay, so this is the line that we have. Now I'm going to plot the points 7 and 6. So 7, that would be, so 7 and 6, 1, 3, 4, 5, 6. So that would be right here. This point here. And so what we're trying to do is we're trying to find the shortest distance between this line and this point. And so the shortest distance is it's the perpendicular distance. So if we sketch a line from this point to this line, the shortest line would be the one that is perpendicular to this line. Perpendicular meaning that it's 90 degrees to this line. So I'm going to just extend this. And so this is going to be, this line is going to be perpendicular to this line. Now, recall that a line that is perpendicular to another line, that when we're looking at the slope of the line, it's going to be the negative reciprocal of the slope of this line. So if the slope of the line that we have is negative 2 over 3, the slope of the line that's perpendicular is going to have to be 1 over this. And then since it's the negative reciprocal, we're multiplying by the negative, so that's going to make it positive. So it's going to end up being 3 over 2. Okay, so positive 3 over 2 is the slope of this line, which is perpendicular to this line. Okay, and so what I'm going to do now is I'm going to find the equation of this line. And I'm going to find the equation of this line because I want to find where this line is going to intersect the original line that we have, the equation that we were given. And so I'm going to write out the general equation for this line. So it's going to be 3 over 2 x plus b. And I'm going to need to solve for b. So in order to solve for b, I'm just going to substitute the point that I have on the line, which is 7 and 6. So substituting this point in, so y is 6 and x is 7. So that's going to be 6 is equal to 21 over 2 plus b. And now I'm going to move the 21 over 2 over to the left. So 6 minus 21 over 2 is equal to b. And so now we need a common denominator when subtracting. So this is going to become 12 over 2. Originally this is 6 over 1, so the common denominator is 2. So I'm going to have to multiply this denominator by 2 and the numerator by 2. Minus 21 over 2 is equal to b. And so that's going to be negative 9 over 2 is equal to b. And so negative 9 over 2 is negative 4.5. So b is equal to negative 4.5. So the y-intercept of this line is negative 4.5. So that would be around, so this is 1, 2, 3, 4, 5. So about here. Now, this sketch is obviously rough, so it's the line that I drew is not exactly perpendicular to this line. So it's just a rough sketch. But if I were to extend this more, right? So it looks almost perfect for the most part. It's just a little bent here, but that's our that's how the line looks like. And now that I have b, what I'm going to do is now I'm going to have to find the point of intersection between these two lines. So the two lines that I have the original equation. So the original is I'm going to keep it as 2x plus 3y is equal to 6. And then this equation here, what I'm going to do with it is I'm going to so the equation we have for this one is actually so it's y is equal to 3 over 2x minus 9 over 2. So what I'm going to do is I'm going to multiply it by 2 to get rid of the fractions here. So this is going to become 2y is equal to 3x minus 9. And I'm going to move the 3x over to the other side. So I'm going to get negative 3x plus 2y is equal to negative 9. Just gonna put a divider here. This is separate. And so our second equation is negative 3x plus 2y is equal to negative 9. So what I'm going to do now is I'm going to use elimination in order to eliminate one of the variables and then solve for the point of intersection. And so to do that, what I'm going to do is I'm going to multiply the first equation by negative 3, and I'm going to multiply the second equation by 2, just so that I'm going to get the same coefficient in front of x for both equations. So the first equation is going to end up becoming negative 6x minus 9y is equal to negative 18. And the second equation is going to become negative 6x plus 4y is equal to negative 18. Yes, negative 18. And now eliminating, what I'm going to get is, so subtracting these, it's going to become 0x. So subtracting these, this is going to be negative 13y. And this is going to become 0. So according to this, y is equal to 0. Okay, so y is equal to 0. So let's see what x would be then. So finding x, all I have to do is just take the y that I found and substitute it into one of these equations. So I'm just going to take the first equation and I'm going to substitute 0 in for y, which is going to give me 2x is equal to 6. So x is going to equal 3. And that's sort of correct. Or it actually is correct. If we look at this sketch, it does appear that this line intersects at 3 and 0. So 3 and 0 is the point of intersection. So now that I have the point of intersection, and I still have the point that was given to me, 7 and 6, what I can now do is I can find the distance between these 2 points. So in order to find the distance between these 2 points, I'm going to use the distance formula. And so the distance formula is, so y2 minus y1 squared plus x2 minus x1 squared. And so the 2 points I have are 3 and 0 and 7 and 6. And so this would be x2, y2, x1, and y1. So going from left to right. So what that's going to be, that's going to become, so substituting these in, so 6 minus 0 squared plus 7 minus 3 squared. So 6 squared is going to be 36. So we're going to have 36 plus 16. So under the square root. And that's going to equal the root of 52, which is, so root of 52 is 7.2. So I rounded to 1 decimal place, just what was asked in the question. So I followed what was asked in the question. So to 1 decimal place, the answer to this question would be 7.2. So 7.2 is the shortest distance between the line 2x plus 3y is equal to 6 and the point 7 and 6. So thank you for watching. If you enjoyed this video, please subscribe to my channel and stay tuned for future videos.